Hello everyone, welcome back to yet another video of OSPF learning series. This is the third video in the series and my intention is to keep the videos short and specific to a topic. We covered the basics of OSPF in the first video and I went over the LSA types in video 2. In this video, I am going to explain all OSPF packet types. Before jumping into that, let me just give you a refresher about LSA. LSA is a basic data unit in OSPF and all the routing information is present inside an LSA. And how these LSAs are being exchanged is controlled by different OSPF packets. There are different types of OSPF packets and they are hello, database description, link state request, link state update, and link state acknowledgement. OSPF packet types are often referred to as OSPF messages, so I might be interchangeably using either of it in this video. Now we are going to look at each of these packets in detail in upcoming slides. The first OSPF message is hello. As I mentioned in the intro video, OSPF forms neighborship dynamically, which means we don't have to specify which are the neighbors like we do in BGP. OSPF uses hello messages to discover and establish neighbor relationship between other OSPF speaking routers. Here in this example, R6 is sending first hello message to the multicast address 224.0.0.5 to check if there are any OSPF routers present on that particular interface. Now R5 got the hello from R6, so R5 know that R6 is a potential neighbor. So R5 send a unicast hello back to R5, which means the destination address on that hello message will be R6 IP address, not the multicast address. So as I said initially, OSPF is able to discover its neighbors using hello messages. But that's not the only role. When two routers form OSPF neighborship, few details on both these routers have to match, and those values will be exchanged in hello messages. Let me explain few of them. The first one is network mask. This is a subnet mask of the interface participating in OSPF. The next one is hello interval, and it is a time interval to exchange hello messages between two routers. The default value is 10 seconds. The third one is options. This field will have different bits used in OSPF to denote different functionalities. I'll explain each one of them during the videos related to those topics. The next one is router priority. The default value is 1 and this is the priority value used in DR-BDR election. So I have explained about DR-BDR election in the first video. The next one is dead interval. This is to tear down a neighborship if a router doesn't hear back from its peer. The default dead interval is 4 times the hello timer. So 4 times 10 is 40 seconds. Which means neighborship will be brought down if the router doesn't get a hello in 40 seconds. The next one is designated router. This will be the router ID of the DR if it is present. Similarly, we have backup designated router ID which will have the router ID of BDR. The last one is active neighbor. If this hello is sent to a specific neighbor, then the IP address of that neighbor would be shown here. Else this field will be 000. I will explain about this in more detail when I go through the OSPF states in the next video. Next packet type is DBD or database description. This has summary of all LSAs present inside a router's database. You can imagine like an index page of a book which shows all chapters inside a book. DBD will have a list of all LSAs available in router's database. Both routers will send the DBD packets to exchange the summary of routes they know. DBD packets also have few other fields. The first one is MTU, which denotes the MTU of interface which this particular DBD is exchanged. As I mentioned, DBD packet will have LSA headers. But if there are a lot of LSAs, then we need to send multiple DBDs as all LSA headers cannot be included in a single DBD. So we need to know the sequence of DBD packets, who should send the DBD first, etc. For that, there are few bits. The first one is init bit, and if this is the first DBD, then init bit will be set as 1. If there are more DBDs to follow after the first DBD, then the more bit will be set as 1. The master slave bit will be set on the master, and this is to identify who should send the DBDs first. These values will be covered in detail when we go through OSPF states in next video. Next one is link state request or LSR packet. If a router needs detail about an LSA from its neighbor, then the router can send a link state request to its neighbor. Basically, link state request will have 3 fields: LSA type, LSA ID, and advertising router ID. LSA type denotes what is the type of LSA which we need, and LSA ID represents what is the ID of LSA which we are requesting for. And advertising router ID will have the address of the neighbor router which we are requesting this LSA from. The next one is LSU or link state update. This is a packet where link state data or actual routes get exchanged in OSPF, which means inside an LSU there will be list of LSAs with the link state information. Also, LSU could be sent as a reply to an LSR or due to any network change. And LSU have these fields: number of LSAs and then each LSAs. The last one is link state acknowledgement. When a router receives an LSA via LSU, that router will send an acknowledgement back to the neighbor to indicate that it has received the LSA. Link state acknowledgement is just like a TCP acknowledgement, and inside link state acknowledgement there will be headers of LSAs which the router is acknowledging. I will be covering OSPF states in next video, and I will be using packet captures to show the messages which we discussed during this video. Hope you liked this video, and thanks for watching.